Example 20.6 busy classroom is on page 754. It is our introduction to the unit decibels, which is intensity level, not intensity, which is sort of confusing. The sound in an average classroom has an intensity of 10 to the negative 7th watts per meter squared. Determine, this is two parts. A says determine the intensity level of that sound. B says if the sound intensity doubles, what is the new sound intensity level? So we're only really given one thing. The intensity in this classroom is 10 to the negative 7th watts per meter squared. We're going to need something else that I will introduce in a second. But the way that intensity level is calculated is with this Greek letter beta, represents intensity level, is equal to 10 times the log of your intensity over your reference intensity, or what we can refer to as the hearing threshold for humans. It's basically the least intense sound that you can hear, the lightest sound you can hear. The intensity threshold for humans is 10 to the negative 12th watts per meter. That's the softest sound that a human could hear. So we just have to plug in these, remember how to deal with logarithms, and go from there. So I'll just worry about this part first. So our intensity is 10 to the negative 7th watts per meter squared. Our reference is 10 to the negative 12th watts per meter squared. 10 to the negative 7th over 10 to the negative 12th is 10 to the 5th. So beta equals 10 log of 10 to the 5th. If you take log of 10 to the 5th, you get 5 times 10, you get 50. Our intensity level is 50 decibels. Since it is a log scale, it is easier for us to put it in decibels to understand things. The way we put pH in a log scale to understand that in easier numbers, we do the same thing with sound intensity. The second part of the problem was, what if you double the sound or double the intensity? Well, instead of being 1 times 10 to the negative 7th watts per meter, now it's 2 times 10 to the negative 7th watts per meter. So my I over I0 is going to be 2 times 10 to the negative 7th watts per meter squared over 1 times 10 to the negative 12th watts per meter squared. You do that calculation, you end up with a value for that ratio of 2 times 10 to the 5th. Okay, beta equals 10 log times 2 times 10 to the 5th. When you go through that calculation, you get 53 decibels. So it might seem weird because you doubled the intensity of the sound, that you only went up by 3 decibels. But this is a logarithmic scale where if you have a 60 decibel sound, that's 10 times a 50 decibel sound. A 50 decibel sound, the decibel sound is 10 times a 40 decibel sound. Like other logarithmic scales, like the Richter scale and pH scale, and so on. One thing that is easy to get confused on that I do want to mention is that if we're just talking about intensity, it's I. But intensity level, oops, intensity level is what we are dealing with in decibels. That's our logarithmic scale. Intensity is just in watts per meter squared. Intensities are hard to understand conceptually for us just because they're in negative exponents. So often we convert these to intensity level to decibels to make it easier for us to understand.